This video will cover the atom, specifically focusing on atomic number, mass number, and isotopes. According to atomic theory, atoms are the fundamental building blocks of elements. Similar atoms form each element, distinct from other elements. Compounds are formed when two or more different atoms bond in simple ratios. Atoms are composed of subatomic particles, electrons, protons, and neutrons. Electrons have a 1 charge and a relative mass of 0. Protons have a 1 plus charge and a relative mass of 1 atomic mass unit. Neutrons have no charge and a relative mass of 1 atomic mass unit. Within an atom, protons and neutrons reside in the dense central nucleus, which is about 10 to the power of minus 13 cm in size. Electrons orbit the nucleus in a much larger region, roughly 10 to the power of minus 8 cm in diameter. The atomic number, denoted by Z, is a fundamental property of an atom. It represents the exact number of protons found within an atom's nucleus. On the periodic table, the atomic number is typically displayed above the element symbol. For instance, 11 represents the atomic number for sodium, Na. A key principle is that all atoms of a specific element share the same number of protons. For example, every sodium atom will always have 11 protons. Let's check your understanding. State the number of protons for atoms of nitrogen, sulfur, and barium. Choose from the provided options for each element. The solutions are as follows. Nitrogen has 7 protons. Sulfur has 16 protons. Barium has 56 protons. In a neutral atom, the net charge is 0. This means the number of protons is equal to the number of electrons. Therefore, the atomic number also represents the number of electrons. The mass number, denoted by A, quantifies the total number of protons and neutrons present within an atom's nucleus. Atomic symbols concisely represent an element. They show the mass number as a superscript and the atomic number as a subscript, both preceding the element's symbol. For example, SODIUM23 is written as squared cubed Na. Here are more examples of atomic symbols. OXYGEN16 has 8 protons, 8 neutrons, and 8 electrons. Phosphorus-31 has 15 protons, 16 neutrons, and 15 electrons. Zinc-65 has 30 protons, 35 neutrons, and 30 electrons. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. This results in different mass numbers. For example, chlorine-35 and chlorine-37 are isotopes of chlorine, both with 17 protons but differing neutron counts. Let's check your understanding of isotopes. Naturally occurring carbon has 3 isotopes, squared C, cubed C, and to the power of 4C. Determine the number of protons, neutrons, and electrons for each of these carbon atoms. Here are the solutions. For squared C, there are 6 protons, 6 neutrons, and 6 electrons. For cubed C, there are 6 protons, 7 neutrons, and 6 electrons. For to the power of 4C, there are 6 protons, 8 neutrons, and 6 electrons. Consider a zinc atom with a mass number of 65. Determine the number of protons, the number of neutrons, and the mass number of a zinc isotope with 37 neutrons. For a zinc atom with a mass number of 65, it has 30 protons. It has 35 neutrons. A zinc isotope with 37 neutrons would have a mass number of 67. Now, try writing the atomic symbols for atoms with the following compositions: 8 protons, 8 neutrons, 8 electrons, 17 protons, 20 neutrons, 17 electrons, and 47 protons, 60 neutrons, 47 electrons. The atomic symbols are as follows. For 8 protons, 8 neutrons, 8 electrons, it's to the power of 6O. For 17 protons, 20 neutrons, 17 electrons, it's cubed to the power of 7Cl. For 47 protons, 60 neutrons, 47 electrons, it's to the power of 7Ag. An atom has 14 protons and 20 neutrons. Determine its atomic number, its mass number, the element, and identify another isotope of this element from the given options. The atom with 14 protons and 20 neutrons has an atomic number of 14 and a mass number of 34. The element is silicon, represented as Si. Another isotope of this element could be cubed to the power of 6x. Atomic masses are measured in atomic mass units, or AMU. Carbon-12 was set as the reference. assigned an exact mass of 12.00 atomic mass units. All other atomic masses are determined relative to carbon-12. The atomic mass, found on the periodic table, represents the weighted average mass of an element's isotopes, considering their natural abundance. This is why atomic masses are generally not whole numbers, as seen with sodium at 22.99 atomic mass units. Using the periodic table, specify the atomic mass for calcium, aluminum, lead, barium, and iron. Round each to the 10th place. The atomic masses are: calcium is 40.1 atomic mass units, aluminum is 27.0 atomic mass units, lead is 207.2 atomic mass units, barium is 137.3 atomic mass units, and iron is 55.8 atomic mass units. Magnesium's atomic mass of 24.3 atomic mass units is an average calculated from its isotopes: 24 megagrams, 78.70% abundance, 25 megagrams, 10.13% abundance, and 26 megagrams, 11.17% abundance, each with specific isotopic masses.